Imagine a world where spring never came back. One moment, Earth was thawing from the grip of the last ice age. Mammoths roamed the tundra, humans were learning to farm, and rivers began to flow again. But then everything changed. In the blink of a geological eye, the planet froze once more. Glaciers advanced, temperatures plummeted, and life teetered on the edge of extinction. This wasn't some slow, natural shift. It happened almost overnight. Scientists call it the Younger Dryas period, a mysterious 1,200-year cold snap that struck just as Earth was warming. But the question that haunts researchers even today is why. Was it a comet exploding over North America? A massive flood of icy meltwater that shut down ocean currents? Or something far more cosmic? Whatever the cause, this sudden freeze reshaped human history, pushing ancient civilizations to adapt, migrate, and survive against all odds. In this documentary, we'll journey back 12,000 years to uncover the secrets of the day Earth froze, and how that ancient disaster may hold the key to our planet's future. 12,000 years ago, the world stood on the edge of rebirth. The Ice Age was ending. The vast glaciers that had buried continents for tens of thousands of years were retreating, and the planet was warming. Rivers surged with meltwater, forests crept north, and the first humans began to settle, farm, and dream of civilizations. For a moment, it seemed like the Earth was healing. But nature, in all its power and unpredictability, had one final twist: a sudden, savage return to ice. Almost overnight, the warmth vanished. Temperatures plummeted, glaciers advanced once more, and the skies turned pale with dust and snow. It was as if the planet itself had taken a deep breath and exhaled winter. This chilling chapter of Earth's history is known as the Younger Dryas period, a mysterious cold snap that struck just as the world was warming from the last ice age. It lasted roughly 1,200 years, yet its arrival was so abrupt, so shocking, that scientists are still struggling to understand how it happened. One moment, the planet's climate was stabilizing. The next, it plunged back into a near-glacial state. And while it happened over a millennium, in geological terms, that's an instant, a blink of the Earth's eye. Imagine the terror of early humans who witnessed this transformation. The rivers that once fed their crops froze solid. Herds of giant mammals, mammoths, mastodons, and saber-toothed cats vanished from the plains. The air grew thin and dry, and snow began to fall where it hadn't for generations. Entire ecosystems collapsed. Humanity, still fragile and scattered, was forced to fight for survival. For them, the gods had turned cold once again. And for scientists today, that sudden chill is a mystery wrapped in ice. Evidence of the Younger Dryas lies hidden across the planet, locked in layers of Arctic ice, buried in lake sediments, and scattered in microscopic clues that tell the story of Earth's sudden freeze. Scientists have found that temperatures across the northern hemisphere dropped by as much as 10 degrees Celsius in just a few decades. In Greenland, the change was even more extreme, a fall of nearly 15 degrees. It was as if someone had flipped a planetary switch, halting the warm flow of the North Atlantic's life-giving currents. But how could something so vast, so powerful, change so fast? For decades, researchers believed it was caused by meltwater floods. As the glaciers melted, enormous lakes formed across North America. Among them, Lake Agassiz, a freshwater sea the size of several modern Great Lakes combined. When its icy dam finally broke, torrents of cold freshwater surged into the North Atlantic Ocean, disrupting the delicate system of ocean currents that carry heat around the globe. This theory, known as the meltwater pulse hypothesis, suggests that the sudden flood shut down the Atlantic meridional overturning circulation, the conveyor belt that keeps the northern hemisphere warm. Without it, Europe and much of North America froze again. But not everyone agrees. A growing number of scientists now point to something even more dramatic: a cosmic event. Around the same time the Younger Dryas began, evidence of a massive explosion appeared in soil layers across continents. Traces of platinum, tiny spherical glass droplets, and nanodiamonds, materials that form under intense heat and pressure. To some, this points to a comet or asteroid that exploded in Earth's atmosphere, raining fire and devastation across the northern hemisphere. The blast could have ignited wildfires on a continental scale, darkened the skies with soot, and triggered an immediate global cooling. If true, it would mean the Younger Dryas began not with a flood, but with fire, an ancient apocalypse from above. Whatever the cause, the effects were catastrophic. The North Atlantic froze over. Arctic winds tore across the plains. Dust storms swept ancient landscapes. In the Middle East, where the first human farmers were beginning to cultivate wild grains, crops failed and entire settlements were abandoned. It was a period of hunger, struggle, and adaptation. Yet it may also have sparked the very foundations of civilization itself. As the earth grew colder, humans were forced to innovate. They built shelters, stored food, and formed tighter communities. The seeds of survival gave birth to the seeds of progress. This paradox, disaster leading to advancement, is one of the most haunting aspects of the Younger Dryas. It reminds us that humanity's greatest leaps often arise from our darkest hours. The cold reshaped not only the planet but the path of human destiny. And when, after 12 centuries, the ice finally began to melt again, the world that emerged was forever changed. Forests returned. Oceans stirred. Humanity took its first steps towards cities, art, and history. But the memory of that sudden freeze, the age when spring disappeared, remained carved into the collective memory of our species. Today, scientists study the Younger Dryas not just to understand the past, but to glimpse our future. The same fragile balance of oceans and atmosphere that once failed could fail again. If it happened before, it could happen now, triggered by human actions, melting ice, or perhaps another cosmic surprise. The story of the Younger Dryas is not just a tale of what was. It's a warning of what could be. Because Earth, as history shows, can change its mind in an instant. 12,900 years ago, as the Earth shuddered under a sudden return to ice, humanity stood at a crossroads. The great warmth that had once promised abundance vanished, replaced by a brutal, unrelenting cold. Across the northern hemisphere, the winds howled with an ancient ferocity. Grasslands turned to tundra. Rivers froze. Seasons twisted out of rhythm. And scattered across this frozen world were small bands of humans, hunters, gatherers, and dreamers, whose lives would never be the same again. In the beginning, they had thrived. The end of the Ice Age had brought prosperity. Mammoths, bison, and giant deer roamed the plains, and humans followed their migrations with confidence and skill. But when the Younger Dryas struck, nature's generosity turned to scarcity. The vast herds began to vanish. The animals that survived grew leaner, harder to track. The plants that once flourished shriveled in the frost. Humanity faced hunger on a scale they had never known. Survival became an art of endurance. Imagine a small group of hunter-gatherers in the Near East, the ancestors of those who would one day build the world's first temples. They wake each morning to an icy wind that cuts through animal hides. Their fires struggle against the cold, and the once fertile valleys lie silent beneath frost. The elders whisper of a time when the earth was warm, when water flowed and trees bore fruit. Now, even the rivers seem to hide beneath the ice. Every journey for food is a gamble between life and death. And yet, amid the struggle, something remarkable begins to happen. Humans adapt. Driven by desperation, they start to change their way of life. No longer able to rely on endless herds, they begin experimenting with wild grains, barley, einkorn, and wheat, that grow even in harsh climates. They learn to gather seeds, to protect them, to plant them near their camps. At first, it's survival, but over generations, it becomes innovation. What began as necessity becomes the first spark of agriculture. Out of hunger, humans learn to shape nature, to bend the land to their will. Archaeologists have found traces of this transformation scattered across the Fertile Crescent, from the dry plains of Syria to the limestone hills of southern Turkey. And at the heart of it all stands one of the most enigmatic sites on Earth, Göbekli Tepe. Built around the end of the Younger Dryas, this ancient temple complex rises like a monument to a forgotten age. Massive stone pillars carved with lions, vultures, and serpents form circles that predate Stonehenge by 6,000 years. The people who built it had no metal tools, no pottery, and no permanent homes. Yet they gathered here, hundreds strong, to shape stone and worship something greater than themselves. Why? Some scientists believe Göbekli Tepe was a response to catastrophe. a spiritual reaction to the trauma of the younger Dryas. As the earth froze and survival became uncertain, humans may have turned to faith, ritual, and community to find meaning in the chaos. The carvings, depicting predators and life cycles, may tell the story of death and rebirth, a symbolic echo of the world's own collapse and renewal. It was here, perhaps, that the human mind began to seek not just survival, but understanding. Across the globe, other groups of humans faced the same test. In North America, the Clovis people, skilled hunters famous for their fluted spear points, vanished from the archaeological record at the same time the younger Dryas began. For years, their disappearance puzzled scientists. Now, many believe they were victims of the same environmental collapse. As the mammoths and mastodons they depended on went extinct, the Clovis culture fractured. Some groups adapted to smaller game. Others migrated, blending into new societies that would later give rise to the first peoples of the Americas. The younger Dryas didn't just freeze the earth. It reshaped humanity's genetic and cultural map. In Europe, the Magdalenian hunters of France and Spain, the last of the great Ice Age artists, also faced extinction. The caves they once painted with mammoths and bison grew cold and empty. Food became scarce. Many were forced to migrate south, following rivers into the warmer valleys of the Mediterranean. In their retreat, human creativity dimmed, replaced by a struggle for existence. Yet even there, the flame of survival never went out. They adapted, learned to fish, to forage, to endure. The cold may have silenced the great art of the Ice Age, but it also hardened the human spirit in Asia, particularly in regions like Siberia and northern China. Ancient peoples faced perhaps the harshest conditions of all. Temperatures dropped so low that even the permafrost deepened. But from these frozen steppes would one day emerge the ancestors of great nomadic cultures, people who learned to ride the storm, to live in harmony with the rhythm of the ice and wind. The younger Dryas, though cruel, taught humanity the value of resilience, a lesson carried through generations. And in the heart of the Middle East, where agriculture was taking root, the story took a different turn. As the younger Dryas ended, the climate suddenly warmed again. The ice retreated, the rains returned, and the fields blossomed. But humanity had changed forever. Those who had learned to sow and harvest no longer needed to wander. Villages appeared, then towns, then cities. The cold had forced humans to cooperate, to plan, to think ahead, and that mindset laid the foundation for civilization itself. The first walls, the first temples, the first shared myths, all born from the crucible of the younger Dryas. What's astonishing is how this ancient climate catastrophe seems to echo in humanity's oldest memories. Flood myths, found in nearly every ancient culture, may be distant recollections of the chaos that followed the younger Dryas. When glaciers melted, seas rose, and floods drowned vast stretches of land. The Sumerians spoke of a great deluge that wiped out humanity. The Greeks told of Deucalion's flood. Even in distant Native American legends, there are stories of fire from the sky and ice that followed. Could these be cultural memories, passed down from the people who lived through Earth's sudden freeze and thaw? It's a haunting possibility that myth and history intertwine in the shadows of this forgotten age. When the younger Dryas finally ended, about 11,700 years ago, the world that reawakened was not the same as the one that froze. Humanity had changed, physically, socially, spiritually. The cold had broken us, but it had also made us stronger. It had forced us to innovate, to organize, to think beyond the next hunt. Out of frost and famine came farming, faith, and the first whispers of civilization. The Ice Age ended, but the human story had only just begun, and so, when scientists today speak of the younger Dryas, they are not merely describing a climatic event. They are recounting the trial by ice that forged humanity's resilience. The day the Earth froze, our ancestors faced extinction, and instead, they discovered transformation. It was a time of darkness that gave birth to light, the frozen dawn of civilization. Deep beneath the Greenland ice, scientists drill into time itself. Each layer of ice is a page in Earth's frozen diary, a record of snow, air, and dust that has fallen for tens of thousands of years. When researchers first examined the layers dating to 12,900 years ago, they saw something that made their hearts race. Within just a few centimeters of ice, representing mere decades, the isotopes changed dramatically. Temperatures had plunged almost instantly. Trapped air bubbles revealed a sudden drop in carbon dioxide, a sign that Earth's lungs had seized. The ice spoke of a world that froze without warning. Something extraordinary had happened. Across the globe, scientists began to find matching clues. In North America, layers of sediment from ancient lakes showed the same abrupt transition. Warm water organisms vanished, replaced by cold-loving species. In Europe, pollen records told a similar story. Forests of birch and pine suddenly gave way to tundra moss. Even in Asia and South America, subtle shifts in temperature echoed the same pattern. This was no local event. The entire northern hemisphere had been thrust back into a mini ice age. The question was, why? For decades, the leading explanation was simple, elegant, and terrifying in its implications: the meltwater flood theory. As the massive Laurentide ice sheet melted across North America, it created an inland ocean called Lake Agassiz, a freshwater monster larger than all of today's Great Lakes combined. Held back by walls of ice hundreds of meters high, it was a ticking time bomb. Eventually, that icy dam gave way. The lake emptied catastrophically into the Atlantic, releasing more than 100,000 cubic kilometers of cold, fresh water in a geological heartbeat. That flood, scientists argue, disrupted the North Atlantic's heat conveyor, the ocean current system that carries warm water from the tropics northward. Without it, the climate of the entire hemisphere collapsed into cold. For many years, this theory fit the evidence perfectly. Ocean sediment cores revealed layers rich in freshwater organisms and depleted in salt-loving ones, proving that enormous volumes of freshwater had indeed entered the Atlantic. Climate models confirmed that such an influx could shut down the Atlantic meridional overturning circulation, the same system that today keeps Europe temperate. The timing matched. The flood, it seemed, had pulled the plug on the planet's natural heater, but science, like nature, is never static. As technology improved, new evidence emerged, evidence that didn't fit neatly into the meltwater story. In 2007, a team of geologists and archaeologists uncovered something strange at dozens of sites across North America and beyond: a thin, dark layer of soil known as the Younger Dryas boundary layer. Within it were microscopic spherules, tiny glassy beads that form under intense heat, and traces of platinum, a rare metal often associated with extraterrestrial impacts. Even more shocking were nanodiamonds, minuscule diamonds created by immense pressure and temperature. These materials, the team argued, could only have formed in a cosmic explosion, the detonation of a comet or asteroid in Earth's atmosphere. If that hypothesis was true, it would rewrite the story completely. The Younger Dryas might not have been triggered by water at all, but by fire from the sky. A comet, perhaps a fragment from a larger icy body traveling through the inner solar system, could have exploded over the Laurentide ice sheet, vaporizing massive amounts of ice in an instant. The blast would have unleashed shock waves, wildfires, and floods, injecting soot and dust into the atmosphere and blocking sunlight. The sudden darkness would have triggered global cooling, plunging the planet back into an ice age. It was a bold idea, one that reignited the debate over how fragile Earth's climate truly is. Skeptics argued that the evidence was circumstantial. Could those tiny glass spheres and nanodiamonds have formed in other ways, from volcanic eruptions, lightning strikes, or natural wildfires? The debate raged on. But the impact supporters pointed to one more astonishing clue: a widespread layer of charcoal dating to exactly the same time period. It suggested that wildfires had swept entire continents, burning forests, grasslands, and the megafauna that roamed them. To ignite fires on such a vast scale, they said, would require more than lightning. It would require an explosion powerful enough to light the skies across the world. Meanwhile, another mystery deepened. Around the same time as the Younger Dryas onset, an entire ecosystem vanished: the great beasts of the Ice Age. Mammoths, mastodons, giant sloths, and saber-toothed cats disappeared within centuries. While humans certainly played a role in hunting them, many scientists believe the sudden environmental collapse was the death blow. Whether by flood or by comet, The Younger Dryas may have been the final chapter in the story of the megafauna, a mass extinction written in ice and fired, as more evidence accumulated. The lines between the two theories blurred. What if both were true? What if a comet impact had melted the glaciers, releasing the very flood that shut down the ocean currents? Some researchers proposed a hybrid explanation. A cosmic explosion over North America triggered the meltwater pulse that then disrupted the Atlantic circulation. In this version, both sky and sea conspired to freeze the planet. It was not one event, but a chain reaction, a domino effect across Earth's interconnected systems. A reminder that in nature, causes and effects are rarely simple. To test these ideas, scientists turn to the Earth's most reliable witness, ice cores. In Greenland, the layers of ice told a precise story of timing. The Younger Dryas began almost exactly 12,900 years ago and ended just as suddenly 1,200 years later. Within that ice, researchers found spikes in platinum concentration, a marker of extraterrestrial material, aligning perfectly with the start of the cold period. But they also found traces of massive freshwater disruptions in the oceans at the same time. Both fingerprints were there, impact and flood. The Earth, it seemed, was telling two stories at once. Beyond the scientific debate lies a deeper truth: how quickly our planet can change. Whether sparked by water or by a comet, the Younger Dryas stands as one of the most dramatic examples of abrupt climate shift in history. The lesson is unsettling. Earth's climate system, driven by delicate balances of temperature, ocean flow, and atmosphere, can tip from one state to another in the blink of an eye. The same fragile engine that sustains life can, under the right conditions, reverse itself in decades. And when it does, everything, from ecosystems to civilizations, must adapt or perish. Today, as scientists warn of modern climate change, they look to the Younger Dryas as both a mystery and a mirror. In our age, it's not comets or floods that threaten to disrupt the currents. It's us. The rapid melting of Greenland's ice, driven by human-induced warming, is pouring fresh water into the same North Atlantic currents that once collapsed. Could history repeat itself? Could the world once again face a sudden freeze in a warming age? The parallels are haunting. The Younger Dryas is more than a story of the past. It's a prophecy written in ice, a reminder that the planet we depend on is not fixed, not stable, not guaranteed. Beneath our feet, in the layers of mud and ice, lies the proof that Earth's balance can snap. And when it does, there are no warnings, only consequences. For thousands of years, the Younger Dryas lay hidden, a silent chapter of Earth's story, buried deep beneath ice, mud, and time. No ancient text recorded it. No myth named it. The world moved on. Civilizations rose and fell, and the memory of that sudden freeze faded into legend. But the Earth never forgets. It keeps its secrets locked away, in layers of ice, in the dust of the ocean floor, in the rings of ancient trees. And one day, modern humans would begin to read those secrets again. The story of the Younger Dryas' discovery begins not with a single person, but with a question: how stable is Earth's climate, really? For centuries, scientists believed climate change was a slow, gradual process, that the world warmed and cooled over millennia, not decades. That belief held true until the mid-20th century, when researchers began drilling deep into the ice of Greenland and Antarctica. What they found there would shatter everything they thought they knew about Earth's stability. Each layer of ice, formed year after year by falling snow, was a frozen time capsule. Trapped inside were tiny bubbles of air, pure samples of ancient atmosphere. By analyzing the ratio of oxygen isotopes within those bubbles, scientists could determine the temperature when each layer was formed. When the first complete ice cores were brought to the surface and examined, the results stunned the world. Around 12,900 years ago, the temperature line didn't slope gently. It dropped like a cliff. The Earth's climate had crashed. In less than a human lifetime, the planet had plunged back into Ice Age conditions. It was the first direct proof that climate could change suddenly. In the 1980s, a team of Danish and American scientists working on the Greenland Ice Sheet Project, known as GSP, produced the clearest evidence yet. Their cores revealed an unmistakable fingerprint, a rapid cooling event followed by a long cold plateau, and then an equally abrupt warming. This pattern, perfectly preserved in the ice, became known as the Younger Dryas signal. For the first time, humanity had undeniable proof of an ancient climate catastrophe. The data was so sharp, so immediate, that some scientists doubted their own instruments. It's impossible, they said. Climate can't shift this fast. But the ice never lies. At the same time, other researchers were uncovering clues from different corners of the world. In lake beds across Europe, microscopic grains of pollen told the same story. Layers that once contained the pollen of oak and hazel, trees that thrived in warmth, suddenly switched to cold-loving plants like juniper and dwarf birch. The change was so sudden that in some cores, it happened between one sediment layer and the next, a time span of just decades. In Scotland, Ireland, and Scandinavia, peat bogs preserved similar evidence. Warmth vanished, and frost returned almost overnight. Further south, oceanographers were drilling into the seabed, pulling up cores of ancient sediment from the depths of the Atlantic. These samples held shells of tiny plankton, foraminifera, whose chemistry changes with water temperature. In the layers dated to the same time as the ice core drop, the shells told the same story, a dramatic cooling of the North Atlantic surface. It was the missing piece linking land and sea. The planet's great ocean currents, particularly the Atlantic meridional overturning circulation, had failed. Something enormous had broken Earth's natural engine. By the 1990s, the Younger Dryas was no longer a geological curiosity. It was the smoking gun in a new understanding of climate instability. It revealed that Earth's climate system is not a gentle pendulum, but a fragile network of thresholds. Push it too far, and it can collapse in the blink of an eye. This realization revolutionized climate science. The idea of abrupt climate change, once dismissed as impossible, became undeniable fact. The Younger Dryas was proof that our planet's heartbeat could skip in an instant, but the discovery also ignited a deeper mystery. What had triggered such an abrupt change? The meltwater theory soon became the frontrunner. Studies of glacial geology across North America uncovered evidence of ancient megafloods, massive spillways cut through rock, carved by unimaginable torrents of water. The most famous of these, the Missoula floods, left behind rippled plains and vast scablands that can still be seen today. Though these particular floods were older, they revealed how devastating a sudden glacial release could be. In Canada, scientists found the ghostly imprint of Lake Agassiz, the vast inland sea whose outburst may have drowned the Atlantic with fresh water. The timing lined up eerily with the ice core evidence. Meanwhile, others chased stranger leads. In 2007, a team studying sites in North America, Europe, and the Middle East announced the discovery of the Younger Dryas boundary layer, a thin sheet of soil, only centimeters thick, but consistent across continents. Within it were metallic grains, microscopic spherules, and traces of platinum far beyond natural levels. It was as if the planet had been dusted with material from space. Even more astonishing were the nanodiamonds, crystals so small they can only form under extraordinary pressure, such as during a meteor explosion. The researchers, this was clear evidence of an extraterrestrial impact. A comet, they suggested, might have exploded over the Laurentide ice sheet, vaporizing massive amounts of ice, igniting continent-wide wildfires, and sending a shockwave of soot into the atmosphere. That soot would have blocked sunlight, cooled the planet, and triggered the Younger Dryas almost instantly. It was a bold, controversial theory, one that divided the scientific community. But whether by flood or by fire, the evidence pointed to one undeniable truth. Something massive had shaken the Earth in the decades since. Technology has deepened our understanding of this frozen mystery. Ice core analysis now extends with pinpoint accuracy, tracing not only temperature but volcanic ash, cosmic dust, and even traces of ancient bacteria. Ocean models simulate how freshwater surges can flip global currents. And climate records from caves, corals, and trees have filled in the gaps, confirming that the Younger Dryas was global, though strongest in the north. What fascinates scientists most is how precisely it ended. Around 11,700 years ago, the ice core data shows another sudden spike, this time upward. In less than a century, temperatures soared by 10 degrees Celsius, marking the end of the Younger Dryas and the beginning of the Holocene, the warm period we live in today. That transition, just as abrupt as the freeze itself, remains one of Earth's greatest mysteries. What caused the planet to thaw so fast? Was it the slow return of ocean circulation? Or did the skies clear after centuries of soot and dust? The Earth, once again, changed its mind, and humanity stepped into a new age. The discovery of the younger Dryas didn't just reveal an ancient catastrophe. It changed how scientists view time itself. It showed that history isn't always written slowly, that the forces shaping our world can strike with terrifying speed. The ice cores of Greenland, the sediments of the Atlantic, the pollen trapped in forgotten lakes, all whisper the same truth. The Earth's climate is alive, dynamic, and unpredictable. It has moods, tempers, and breaking points. Today, as modern researchers stand over drilling platforms in the Arctic, they are not just looking into the past, they are staring into the future. Each bubble of ancient air reminds us that what happened 12,000 years ago could happen again. As human activity warms the planet and glaciers melt once more, the same mechanisms that triggered the younger Dryas are stirring. Ocean circulation is slowing. Fresh water is pouring into the North Atlantic. The patterns look disturbingly familiar. The discovery of the younger Dryas was a scientific triumph, a revelation born from ice and patience. But it is also a warning etched in the Earth's memory that our planet's climate can shift not in millennia, but in moments. The same fragile systems that froze the world once before are still with us, beating beneath the surface. The past, it seems, is not as far away as we think. When the world began to thaw, it did not do so gently. The ending of the younger Dryas was not a peaceful sunrise over a frozen land. It was chaos, violent and sudden. Across the northern hemisphere, ice that had stood for 1,000 years began to crack, roar, and die. Mountains of frozen water collapsed into valleys. Rivers burst through glacial walls with the force of 1,000 storms. Seas rose. Winds howled with dust and meltwater mist. The planet was awakening, but it was a brutal, trembling awakening. For the small, scattered bands of humans who had endured the deep cold, survival was both a triumph and a curse. They had learned to live in a world of scarcity, where every sunrise was a gift, every hunt a battle. Then, without warning, everything changed again. The snowfields melted beneath their feet. The animals they depended on, mammoths, giant elk, and woolly rhinos, began to vanish. Forests crept northward, transforming tundra into woodlands. What had once been a frozen wasteland now turned into a world of mud, flood, and confusion. The people who had adapted to ice suddenly found themselves in a swamp of melting earth. Imagine it. Entire landscapes disappearing beneath torrents of meltwater. Valleys carved by rivers that hadn't existed the year before. Lakes swelling, bursting, and redrawing maps overnight. In North America, the vast Laurentide ice sheet was collapsing, releasing meltwater at unimaginable scales, rivers larger than any today. They thundered into the Atlantic, reshaping coastlines, drowning plains, and scattering life wherever they touched. In Europe, the retreating glaciers uncovered lands unseen for millennia. And from beneath the melting ice came the roar of rebirth, volcanoes awakening, soil breathing again, and winds carrying the scent of a planet starting over. But rebirth comes with loss. The abrupt warmth unleashed a wave of extinctions that echoed across continents. The giant mammoths, symbols of Ice Age power, were the first to fall. Their massive bodies, adapted to the frozen steppes, could not survive the heat, the floods, and the shrinking grasslands. The woolly rhinoceros, the Irish elk, the saber-toothed cats, the short-faced bears, all vanished within a blink of geological time. The giants of the cold had ruled for tens of thousands of years, but they could not outrun the sudden fever of the earth. And as the animals died, so too did the old ways of humankind. The great hunters of the Pleistocene, who had learned to track mammoths across endless snow, now faced a new enemy, uncertainty. Their weapons, their rituals, their survival instincts, all were built for a world that no longer existed. Tribes that had thrived in the Ice Age found themselves wandering lands of melting ice and rising seas, their traditions breaking apart with the glaciers. Entire cultures faded into the fog of prehistory, leaving behind only tools buried in thawing soil. Yet, In the midst of destruction, something remarkable was happening. From the ashes of extinction, humanity began to adapt again. Faster, smarter, more inventive than ever before. The end of the Younger Dryas forced the birth of a new kind of human. In the warming Fertile Crescent, people who once roamed as nomads began to settle near rivers that flowed from the melting mountains. The floods that destroyed the old world also nourished the new, feeding the valleys with rich soil, perfect for crops. And so, amid the chaos of a reborn Earth, the first seeds of agriculture were planted. Civilization itself was being born from the ruins of the Ice Age. The transition was not smooth. Across the Middle East, rainfall patterns shifted unpredictably. Some regions became lush and fertile, others turned to dust. Communities fought to survive, to control the water that now dictated life and death. The first irrigation ditches appeared, carved by desperate hands trying to tame the floods. Fire, once a tool for warmth, became a weapon for clearing land. Humans began reshaping the earth, not merely to endure it, but to command it. The same forces that had once humbled them under ice now drove them to rise above nature itself. Still, memories of the cold lingered in their myths. The flood stories that appear in the world's oldest civilizations, from Mesopotamia to the Americas, may all trace their roots to this violent rebirth. When ancient people spoke of gods drowning the world, of great waters that swept away cities, they were remembering the chaos their ancestors had seen with their own eyes. The Younger Dryas had not just shaped the land, it had burned itself into the human soul. Every generation carried whispers of that terror. The day the world froze, and the day it melted again, as the warmth took hold, the Earth's landscapes transformed beyond recognition. Glaciers retreated into the high north, revealing new coastlines and islands. The meltwater poured into the oceans, raising sea levels by more than 100 meters. Where once there had been vast plains connecting continents, there were now seas. The Bering Land Bridge between Asia and America sank beneath the waves, cutting off migration routes forever. In northern Europe, the icy plains gave way to forests of birch and pine, then oak and elm. In the Americas, vast tundras became grasslands, rivers swelled into great lakes, and new ecosystems bloomed. But for those who lived through it, beauty was mixed with fear. The climate no longer felt stable. The sun's warmth, once longed for, now brought destruction as easily as life. Thunderstorms raged with unfamiliar fury, and strange seasons came and went without warning. People who had learned to trust the cycle of the stars now found the sky unpredictable. Their survival depended on constant adaptation, watching, learning, inventing. It was in this crucible of uncertainty that human intelligence sharpened into what it is today. Necessity did not just drive invention. It forged the human spirit itself. The Earth, too, was reborn, scarred, but alive. The great glaciers left behind fertile valleys, filled with minerals ground from stone. Rivers like the Nile, the Tigris, and the Euphrates became the arteries of a healing planet, carrying life into deserts and plains. The dust from the melting ice fed oceans with nutrients, sparking blooms of plankton that restored balance to the atmosphere. Every catastrophe had left behind the seeds of renewal. The Younger Dryas had reset the planet, and in its aftermath, both nature and humanity began a new chapter. Yet the scars of that ancient chaos still lie hidden beneath our feet. Buried deep in the ice cores, in sediments at the bottom of the sea, in the DNA of our species, reminders of how close life once came to vanishing. The people who endured that time became the ancestors of us all. Their resilience is written into our blood, their fear into our stories, their hope into our drive to survive. The Younger Dryas was both the end of one world and the violent birth of another. The world we now call home to it is humbling to remember that every city skyline, every field of wheat, every human heartbeat, all exist because our planet survived its greatest test. The last ice age tried to erase life, but instead, it forged it stronger. The rebirth of the planet was not a miracle. It was a consequence of chaos, of change, of the delicate balance that governs everything. The aftermath of the Younger Dryas reminds us that the same elements that destroy can also create. Fire melts ice, floods feed life, and death gives way to evolution. In the grand rhythm of Earth's history, destruction and creation are never separate. They are partners in the same eternal dance. And so, as warmth returned and the first humans began to look upon green valleys and open skies, the Earth itself seemed to breathe again. When the younger Dryas finally released its grip, the world did not simply warm, it transformed. The scars of ice carved new valleys. The rivers born from melting glaciers carved the maps of our future. And on those riverbanks, humanity stood blinking into the new sunlight, a species forever changed by cold, hunger, and fear. The Ice Age had ended, but its shadow lingered in the instincts and imaginations of those who survived. In that fragile warmth, the first sparks of civilization began to glow. Across the Fertile Crescent, a wide, curving stretch of land from the Mediterranean coast to the plains of Mesopotamia, the survivors of the long freeze found a new rhythm to life. For thousands of years, their ancestors had followed herds across frozen plains. Now, the herds were gone, and the land itself offered something different: abundance. As glaciers retreated, rains returned, and rivers like the Tigris, Euphrates, and Jordan swelled with meltwater. The soil, enriched by the dust of crushed mountains, became fertile beyond imagination. Here, around 11,000 years ago, the first humans began to settle, sow seeds, and wait for growth, a new act in the human story. These were the Natufians, the bridge between hunter and farmer. They built semi-permanent homes from stone and clay, storing wild grains, experimenting with the idea that food could be grown, not chased. This revolution did not happen overnight. It was a whisper that became a roar. Each generation learned a little more: how to harvest, how to irrigate, how to survive without moving. By 10,000 BCE, the descendants of these Ice Age survivors had transformed the simple act of planting into civilization's greatest invention: agriculture. It was the beginning of the Neolithic Revolution, the first human response to the chaos the younger Dryas had left behind. But it wasn't only seeds that were planted. Ideas took root too, about gods, balance, and the fragile nature of life. The people of this warming world still carried memories of when the sky had turned cold, when snow buried their ancestors and beasts vanished. Their myths began to reflect those fears. In every early culture, from Mesopotamia to the Indus, echoes of the younger Dryas survive in legend. Flood myths, stories of divine wrath, and tales of rebirth all speak to a collective memory of a planet that had once destroyed nearly everything. The ancient Sumerians spoke of a time when gods washed the earth clean. The Greeks told of Deucalion's flood. The Hebrews told of Noah. Even far across oceans, the Maya, the Hopi, and the peoples of Polynesia remembered a world drowned and reborn. These were not coincidences. They were trauma turned into theology, history retold in the only way early humans could explain it: through gods. The warming also gave birth to something else: time. In the unpredictable chaos of the younger Dryas, seasons had been unreliable. Now, for the first time in thousands of years, the cycle stabilized. Spring returned predictably, rivers flooded rhythmically, stars rose where they should. Humans began to measure, to record, to anticipate. Calendars were carved into bone and stone. Constellations were charted. The need to understand the sky, to predict whether the next year would bring flood or famine, was a lesson learned from centuries of climatic fear. Civilization, at its core, was humanity's answer to uncertainty. As the ice melted, so did the boundaries between worlds. The sea rose, swallowing ancient plains and cutting off lands once connected. The Persian Gulf, now filled with warm waters, had once been a vast valley where rivers converged, a cradle of early life, now drowned. Along its edges, displaced peoples gathered, adapting, building. To the west, the Nile Valley flourished. Its floods, fed by African rains, created a rhythm of life so dependable that entire cultures formed around its pulse. This was where the first engineers were born, humans who built channels, dikes, and storage basins, mastering water as if mastering fate itself. They did not know it, but they were echoing the ice, controlling flow, shaping landscapes, commanding nature rather than submitting to it. In the highlands of Anatolia, another miracle emerged: Göbekli Tepe. Long before the pyramids or Stonehenge, People who still hunted and gathered stones weighing tons, carved with lions, vultures, and serpents, and raised them in circular temples to the sky. No one knows exactly why, but perhaps it was gratitude, a monument to survival, a plea to never endure the great cold again. The carvings on those pillars, of fire, of falling stars, of beasts, hint at cosmic memories. Some scientists even suggest Göbekli Tepe may encode the memory of the younger Dryas impact itself. If true, it means the first temples of humankind were built not for gods of war or harvest, but for remembrance. As millennia passed, the warmth deepened. The Holocene stabilized, and humanity multiplied. Villages grew into towns, towns into cities, cities into empires. The knowledge born of survival, how to plan for drought, how to store food, how to read the heavens, became the foundation of governance and religion alike. In Mesopotamia, priests watched the skies for signs of divine anger, fearing another age of cold or flood. In Egypt, the Nile's yearly rhythm was worshipped as the heartbeat of the gods. In every culture, the line between climate and faith was invisible, because to the early human mind, the planet itself was divine. Yet even as the warmth nurtured civilization, the memory of instability never truly vanished. Early architects built monuments aligned precisely to the solstices, as if to ensure the sun would return each year. Farmers celebrated harvest festivals that doubled as rituals of protection against the wrath of nature. The great ziggurats of Ur and the pyramids of Giza were not just tombs or temples. They were symbols of permanence in a world that had once proven nothing lasts forever. Meanwhile, far to the east, the meltwater-fed plains of the Indus Valley were taking on life. There, humans engineered entire cities with drains, reservoirs, and brick homes, a sophistication born of necessity. Their survival depended on taming a climate that could still shift violently. Monsoon rains could turn blessings into destruction, just as the younger Dryas had once turned warmth into ice. Every canal, every wall was a memory carved in mud, a promise that they would never again be helpless before the Earth's moods. Even across the sea, the echoes of the Ice Age shaped destiny. In the Americas, as the glaciers receded from the Rockies and the Andes, lush valleys opened. People who had once followed mammoths now followed rivers, planting maize and beans where ice had once ruled. And though they were half a world away, their myths too spoke of floods, of fire from the sky, of gods who destroyed to renew. The younger Dryas had written a universal story, one that humanity carried everywhere it went. Every civilization that rose in the Holocene owed its existence to that violent ending. Without the younger Dryas, the transition from ice to warmth might have been slow and smooth, too gentle to provoke invention. But the trauma of collapse forced humanity to adapt faster, think harder, and plan longer. In a way, the first cities, the first writing, the first empires, all were children of catastrophe. The freeze taught humans fear. The thaw taught them ambition. By 5000 BCE, the last major glaciers had retreated into the polar north, and the Earth settled into the relative calm we know today. But the lessons of the younger Dryas were etched into every aspect of civilization. Laws were created to preserve order against chaos. Religions taught balance between gods, between man and nature. Even art changed. Paintings moved from caves to clay tablets, from survival scenes to stories of creation and rebirth. It was as if humanity, having survived the world's end, could finally imagine something greater than fear. Meaning, still, there were warnings. Every drought, every flood, every eclipse reminded people that the old chaos could return. The Earth, they knew, was alive and fickle. And perhaps that is why our ancestors built so high, carved so deep, and dreamed so boldly, to defy the memory of the ice, to leave something that would outlast even the next great change. The dawn of civilization was not just a rise from darkness. It was the echo of a frozen past, reshaped into progress. The younger Dryas had humbled humanity, but it had also prepared it. It taught us to record, to remember, and to build. The Ice Age may have ended, but its spirit still moves through every invention, every myth, every act of creation we undertake. Because the first humans to plant seeds, raise stones, and tell stories were not just survivors. They were witnesses to the rebirth of the world. The younger Dryas is long gone, but its shadow stretches into our time. For centuries, scientists treated it as an ancient curiosity, a strange anomaly buried in the frozen archives of the past. But as the 21st century unfolds, those icy records have begun to sound like a warning. The same forces that once froze the Earth in a heartbeat are stirring again. The story of the younger Dryas is no longer just history. It is prophesied in the quiet laboratories of climate research stations. From Greenland's Summit Camp to Antarctica's Concordia Base, scientists are drilling deeper than ever before, extracting cylinders of ice that preserve over 800,000 years of Earth's memory. Each bubble of trapped air tells a story of atmosphere and change, and the patterns they reveal are hauntingly familiar. Around 12,900 years ago, during the younger Dryas, the world cooled sharply after a period of warming. Today, we are witnessing the opposite, a rapid warming after a stable interglacial. But the mechanisms, the tipping points, and the dangers share an eerie symmetry. The leading theory of the younger Dryas centers on a sudden disruption of the Atlantic Meridional Overturning Circulation, AMOC, the great ocean conveyor that moves warm water northward and drives global climate stability. During the Ice Age, as North America's glaciers melted, vast floods of fresh water poured into the North Atlantic, reducing the ocean's salinity. Without salt to make surface water dense enough to sink, the conveyor slowed, and the heat transport collapsed. The North Atlantic froze, and global temperatures dropped in less than a human lifetime. It was a system failure, swift, brutal, and self-amplifying. Today, scientists are seeing the same signs, this time in reverse. Greenland's glaciers are melting faster than ever recorded. Every year, over 270 billion tons of ice flow into the ocean. Satellite data shows freshwater spreading like a bright blue stain across the North Atlantic. Oceanographers measuring deep currents beneath the surface report weakening flow. And climate models, fed with this data, reveal a frightening possibility. If the AMOC slows too far, or worse, shuts down entirely, it could plunge Europe and North America into chaos once again, not from ice, but from climate whiplash. It wouldn't mean another ice age in the traditional sense. Instead, weather systems would collapse in unpredictable ways. Europe freezing even as the tropics overheat, monsoon cycles failing, agricultural zones shifting in a single generation. The memory of the younger Dryas shows that such transformations do not take millennia. They can happen within decades, within the lifetime of a civilization. But what makes today's situation even more perilous is that this time, the trigger is not nature. It's us. During the younger Dryas, a single pulse of meltwater may have been enough to tip the planet into a 1,000-year freeze. Now, human industry releases billions of tons of carbon dioxide every year, altering not just temperature, but chemistry, circulation, and feedbacks across the entire Earth system. Scientists studying ancient ice cores can now overlay the past with the present, and the speed of change we see today is faster than anything in those ancient records. What took centuries before is happening in decades. One of the most sobering discoveries came from isotope data in Greenland's ice. It revealed that at the end of the younger Dryas, the world warmed by as much as 10 degrees Celsius in less than a century. For decades, that seemed like a distant, unrepeatable event. But today, with atmospheric CO2 levels higher than at any time in the last 3 million years, we are approaching the same conditions. Only this time, the warming has no natural break. The younger Dryas prove that Earth's climate can snap. Our age may prove that it can snap in the opposite direction. In 2018, the Intergovernmental Panel on Climate Change, IPCC, released a landmark report warning that the planet's systems are nearing thresholds, points beyond which feedbacks become irreversible. Permafrost melting releases methane, a greenhouse gas far more potent than CO2. Ice loss reduces reflection, amplifying heat absorption. Ocean warming kills phytoplankton, the microscopic organisms that store carbon. Each of these is a domino, and the younger Dryas showed how quickly dominoes fall once the first one tips. But beyond the data, there is something more haunting: the emotional weight of recognition. The landscapes where the younger Dryas unfolded are still with us. Greenland's ice sheet, the North Atlantic's deep currents, the tundras of Siberia, they are not ancient relics. They are active players in our story, still holding the power to decide our fate. When scientists travel to the Arctic today, they are not just exploring history. They are walking across the threshold of tomorrow. The same glaciers that once froze a world are now retreating faster than at any point in human existence. The Earth is whispering, and the echo sounds all too familiar. The lessons of the younger Dryas have changed how science views climate forever. It taught us that Earth's system is not linear. It does not respond gradually to change. It leaps, it collapses, it rebounds. The concept of tipping points, now a central idea in modern climate science, was born from studying that sudden ancient freeze. And it showed us something even more profound, that human civilization, fragile as it is, depends on the narrowest of margins. The entire history of agriculture, cities, and culture has unfolded within a climate window of less than 2 degrees of global variation. The younger Dryas reminds us what happens when that window slams shut. In universities and research centers, models now simulate the future using the past as a guide. Supercomputers recreate the younger Dryas event to test how ice melt, ocean currents, and atmospheric shifts interact. The results are unsettling. Many scenarios that reproduce the younger Dryas cooling can be triggered by conditions not far from where we are today. A slight slowdown of the AMOC, a burst of freshwater input, a spike in greenhouse gases, and the delicate rhythm of Earth's climate begins to stutter. The difference is that in the past, humanity was a passenger. Today, we are at the wheel. Some scientists see hope in knowledge itself. Because we understand what happened before, we can prepare, adapt, and act. The younger Dryas showed that even after catastrophe, the planet can recover, balance can return. But it also showed that recovery takes time measured in centuries, not human lifetimes. The civilizations we know could not simply wait for the Earth to heal. To survive, we must change faster than the planet changes us. The past has already left its warnings written in stone and ice. In 2021, researchers studying the Greenland ice cores found a new layer, a modern fingerprint of industrial pollution, visible even in the planet's most isolated regions. Just as the younger Dryas left its mark in the chemistry of ancient layers, our age is now leaving its own. Future scientists, drilling thousands of years from now, will see the same story in reverse. Not a freeze, but a burn. There is a growing belief among climatologists and historians alike that the younger Dryas was more than a natural accident. It was a message, an example of how quickly stability can vanish. The same Earth that nurtures life can also test it. The same balance that allowed humanity to rise can fall apart in an instant. Our ancestors faced this without technology, without warning. We face it with knowledge and with choice. Standing on the edge of a melting glacier, one can feel both awe and dread. The silence of ice, the sound of dripping water, the deep creak of a shifting sheet. They are the language of the planet reminding us of its power. The younger Dryas was once the world's cold breath. Today, its ghost lingers in the warmth we have created. Whether we listen to that ghost or ignore it will define the next chapter of our species. In the end, the story of the younger Dryas is not just a story about climate. It is about connection. It reminds us that Earth is not separate from us. It is part of us. Its memory is our memory. Its survival, our survival. The ice has spoken once before. It may speak again. The question is, will we hear it? The Earth has always remembered. Every storm, every shift, every heartbeat of its ancient rhythms is recorded in the quiet language of sediment and ice. When we look deep enough, the planet speaks, not in words, but in evidence. And among the billions of years written in its memory, few moments shine as brightly or as coldly as the younger Dryas. It was an age when nature flexed its unimaginable power, when survival depended not on dominance, but on humility. Now, as humanity stands at the edge of another transformation, the story of that ancient freeze feels less like a chapter of the past and more like a mirror held to the present. The world today hums with the noise of progress. Engines, cities, satellites, digital dreams orbiting above a fragile blue sphere. We've built civilizations that pierce the clouds, machines that mine the stars, and systems that connect billions in an invisible web of light. But beneath